So like Heather said, we're talking about APs today. So kind of features, capabilities of APs, very high level. So we're not going to get too much into the weeds about like specific configurations, but we'll definitely talk about kind of just overall features and kind of what to look for in terms of what an access point can do. Yeah, we'll just jump right into it. Um, there we go. So the main thing to think about with access points and just a wireless infrastructure in general is that you want to have a good design. So designing a good network and making sure that you're able to meet the needs of that most important client that's also your least capable. So you want to make sure that your client devices are actually able to connect to your network. That's kind of the main point here. So some things to think about um, are those older legacy devices that may not have the newer feature set, or another thing to note too is that these days you're having users that are connecting and utilizing multiple devices at a time. So you have to kind of think about what is that device that a user's using, whether it's like a warehouse scanner or their phone, or it could even just be the laptop that they use is the least capable. So you need to verify that the client side, so the PHY supported on the client, the number of spatial streams, the number of radios, the client devices, those kind of things are important when it comes into selecting which AP will work best for you and your environment. And then some overall features and how to identify them. So I know a lot of manufacturers like to kind of hype up and use marketing buzzwords for the most part, and say, hey, our AP can achieve the highest theoretical speed that's possible by a given PHY. So you need to kind of realize that you're not going to always get exactly what's on the data sheet in terms of throughput numbers, but it's at least a good starting point to know and kind of identify the actual feature set of a given AP. So AP product overviews, data sheets, they can be very overwhelming when you're looking at them. So they'll list out specific antenna arrays that are in an AP. They'll list out like I said, the PHYs that are supported, the data rates, um, everything associated with that AP, and you're looking at it in a sheet, and it can just be very overwhelming to look at. So that's why going back to that most important, least capable client, having an idea of what your clients um, require helps kind of ingest that data as you're looking at it for a given access point. Some other things to keep in mind too is that there are multiple configuration options for an AP. So think of it standalone APs. So that's more like home small business environments where you're configuring one or two APs in a given infrastructure, or controller-based APs where you're deploying hundreds, maybe thousands of APs, and you're configuring all of the different settings and options in a centralized location. So whether that's an on-premise physical hardware controller or even cloud managed APs, it's still controller based, still in a centralized location. So there are pros and cons of each of those. And just kind of realize that each one meets different needs essentially. So kind of the differences between on-prem versus cloud controller architecture. So the on-prem side is very much the traditional LAN side architecture. Um, the biggest thing here is that internet connectivity isn't necessarily a requirement to get your wireless set up. So if you just wanted to have um, access to just internal resources or something like that, you have a lot of flexibility whenever you're deploying on-premise controllers. So most of your kind of enterprise environments, at least that I've dealt with in the past, it's kind of a we're kind of moving more towards where APs are cloud managed, but most of my experience in the past is on-prem kind of standalone controllers that are used to kind of help manage everything. It allows for kind of some complex wireless deployments as well. The nice thing about cloud managed side though is just it's very easy to use. You plug in an AP, it automatically joins to your instance in the cloud. It allows for some flexibility. It makes scaling out a network a lot easier as well. The other big thing about cloud management, APs in particular, is the maintenance on those. So firmware updates, the software updates in general, much easier to manage through the cloud, where the cloud hosting environment is typically doing those on the back end. So you don't have to worry about hardware failing in terms of the controller side and updating code, that kind of thing. It makes keeping your equipment up to date much easier and much uh, uh, kind of standardizing it in a way to where you don't really have to plan as far ahead in terms of doing a full code upgrade on a controller that is going to potentially cause downtime, that kind of thing. So some things that you can kind of see in terms of APs, dual band. I'm sure you guys have heard of dual band, tri-band, maybe even quad band. So this is kind of some terminology that you'll see when you're looking at APs. So dual band, think of it as just two separate bands. So typically that's 2.4 and 5 gigahertz. The tri-band, you have 2.4 and 5, even 6 gigahertz with 6E now. You can also have 2.4 and two dedicated 5 gigahertz bands as well. So just three separate radios in that instance. And then we even see quad band these days. These are great for kind of a mesh deployment in particular. So you'll have your 2.4 for your legacy devices. You'll have a dedicated 5 gig, typically for your backhaul, so connecting your APs together in that mesh deployment. You'll have a 5 gig for client activity, and then also a 6 gigahertz band serving clients as well. So one thing to keep in mind is that most of your clients that you see um, kind of out in the wild are typically 2x2 spatial streams devices. So they have two radios for transmitting and receiving. Um, and then the different PHYs, here's a chart that kind of breaks it down. The year that it was ratified, the band that it's associated with, the maximum theoretical data rate connected, and width of channel also comes into play. So like for example, N does not support 80 and 100 megahertz wide channels. So the big thing with AC and AX also is increasing that number of spatial streams to up to 8 as well. Um, yeah. And then some other things to kind of keep in mind is the MIMO features. So this is really big, introduced with Wi-Fi 5. It was limited to download only in Wi-Fi 5. But this is where An AP is able to use all of the spatial streams to serve clients. So let's say, for example, you have two clients, like I said previously, most of your clients are 2x2 devices. So if you have an AP that's a 4x4 AP, you can serve both of those clients at the same time with multi-user MIMO, for example. Um, and then with single user, it's just one device at a time. So those are the two biggest things there to keep in mind. It definitely allows for increasing your capacity on your network. And then here's a photo of a kind of the internals of a AP. So you can see the different radios here, right here, are the antennas going to the specific radios. So the 2x2, 3x3, 4x4, 8x8, what are we really talking about when we say that? It's the number of the antennas. So the number of transmit antennas, the number of receive antennas. And then typically if you see it written in that 2x2 with a colon and then another number, that's the number of actual spatial streams. So how many of those transmit antennas can we utilize to actually send data? That's what we mean by the spatial streams. So again, with multi-user MIMO, if you have an 8x8 AP and you have nothing but 2x2 clients, that's 4 clients you can communicate with at a given time. So you can serve more traffic and more clients with that multi-user MIMO. Some different operating modes of AP. So you can think of these as kind of how the APs are working in the environment. So you have a few different options here. So locally switched, where the AP is treating the client as though it's same as it would be when that client's connected to a switch. So everything is kind of um, sent out. All the data traffic is sent directly out of the AP into the network, and then it kind of traverses accordingly. And then centrally switched would be kind of, think of it more as where your data is encapsulated in a tunnel back to your controller, for example. And then all that data traffic is actually coming out of the controller instead of the AP directly. So you can kind of pick and choose where you would like the data traffic to egress into your network. And then you also have bridged mode. So you can set the APs into, say, like a workgroup bridge where you're just extending your part of your network wirelessly, for example. So it's essentially using Wi-Fi as your backhaul or as your cabling to connect a different segment into your network. Some other things that AP support, so they can be um, supporting more network management features. So you can turn an AP to where it's no longer supporting or allowing clients to connect to it, but it's doing spectrum analysis. It's doing a sniffer to where you're doing like packet captures with the access point, or even turning it into a monitor mode where you're doing rogue detection. You're doing intrusion detection, intrusion prevention, those kind of things with the access point. So instead of serving the clients, you're actually using it as more of a network management feature itself. Another thing to keep in mind is how many SSIDs, how many networks are you going to be broadcasting? Because depending on the AP, depending on the vendor, there are restrictions in place. So I think Ubiquity, for example, maximizes it, or you're limited to a total of like 8 SSIDs. Cisco, Aruba, all of those other manufacturers, you have up to 16. Just because you can do 16 SSIDs doesn't mean that you should do 16 SSIDs broadcasting. So one thing to keep in mind is that For each of those SSIDs, your AP will constantly send out beacons or advertise uh, those specific networks. So they're advertising their AP name, they're advertising the capabilities of that network. Um, so if you're and typically those are sent out roughly every 100 milliseconds. So let's say you have a dual band AP, you have 5 SSIDs. So that means that you're sending out 10 beacons, 10 frames every 100 milliseconds. So it quickly starts to add up, and that's airtime that your clients can't use at that point. You're congesting the channel just on your beacon frames at that point. So try to limit your SSIDs to as few as you can. Um, and another thing to note about the beacon frames as well is that they are broadcasted at the lowest mandatory data rate of your AP. So if you're still supporting 802.11b clients and you have, say, 1 megabit per second data rate enabled, all of those beacons are also going to be sent out at a 1 megabit uh, per second data rate. So it really is a easy way to add in congestion, add in um, to where you're unable to really serve the clients that you need to, because you're causing overhead on the network, and yeah, it directly impacts your client experience. It directly impacts the um, yeah, the experience of your end user. So if they're complaining about kind of poor signal or just poor Wi-Fi in general, and you have 10, 12 SSIDs, that you're kind of hurting yourself at that point. Another thing to keep in mind is guest access. So a lot of us are managing a network or managing an environment that we want to provide um, wireless access to visitors. So if you have an office space and you have a vendor come in, you want to provide them with some way to connect to the internet. There's a lot of different ways to configure this based off of the feature set of a given AP. So it can be very simple to where it's literally just a second SSID. It can also get very complex to where you're isolating that other SSID into its own VLAN, and then it's completely segmented out of your corporate network. You can isolate clients as well, so clients are not able to communicate with each other when they're connected to a given network. There's also options for configuring captive portals for guest networks. So um, some things to keep in mind in terms of creating your guest environment for your users that are kind of visiting your network. The other the other big thing to keep in mind too are the security features. So which version of WPA are you going to use? Are you going to use security? Are you going to have an open network? A lot of your guest networks, for example, typically um, don't have a encryption method that they're using. So you're not using WPA2 for your other networks. Are you using a pre-shared key? Are you using some type of EAP authentication? Are you going to use like username, password, certificates to authenticate? So keep those things in mind as well. You can also have a firewall or ACLs uh, built into the access point, so you can limit the the traffic that a given client can connect to, or that kind of thing. You can do MAC based filtering. So a given MAC address, it needs to be in a database for that client to connect to your AP. You can also set up role-based access. So if you have a large team, for example, that's managing your wireless deployment, you can a lot of the time specify which section of the configuration that they have access to. Maybe you want your help desk to be able to add users to allow them to connect to your through your captive portal, for example, on your guest network, but you don't want those help desk users to be able to make configuration changes on the network. You don't want them to be able to change channels of APs, that kind of thing. So a lot of the vendors will allow you to kind of specify what level of access um, your uh, your management users have. Another thing to keep in mind too is that a lot of these APs have their own built-in intrusion prevention system. So they have um, metrics and they have kind of um, traffic patterns that they're looking for that indicate maybe something is going wrong or someone is trying to access your network. Um, so they have whips kind of in place or intrusion prevention systems that prevent those kinds of attacks from disrupting your network. And then another thing to keep in mind too is how are you powering your APs? So is PoE supported? What amount of power are your given APs requiring? Is it just PoE where you only need the 15 watts? Is it PoE plus where it maxes out at 30? Or is it PoE plus plus where you are using a lot of features of your AP and that AP is drawing significant amount of power up to 100 watts for PoE plus plus or 802.3 BT. So a lot of these newer APs that are adding in quite a bit of features are requiring more and more power. So that keep your power requirements in mind when you're selecting APs, when you're kind of updating your wireless infrastructure. I know a lot of customers are starting to do AP refreshes, for example. So moving to new hardware, you want to make sure that your switch environment or your switches um, have the power budget on them to support those new APs. You don't want to get to where you're not able to fully power an AP and you're losing some features. So there are some instances where you can connect an AP to a PoE plus port and it will disable some features. So it won't use the full feature set um, of that AP whenever it's not fully powered. So, and that's it. So if there's any questions, yeah. Do you see any questions, Heather?
Taking a look now. Nothing in the panel yet, but if anyone has questions, go ahead and throw them in there. Jack, you must have just done such a fabulous job. Let me check the chat as well. That would be a record if we didn't have any.
Anything?
Let's see. Oh, here we go. Have you ever seen any real life examples of multi-user MIMO?
Yes. Not often, to be honest with you. So one thing we track that with our Sapphire Eye product. It's one of the KPIs that we are kind of showing. Typically, in most environments, we're not seeing a lot of utilization. I think the most I've ever seen in an environment is like maybe 5% utilization. So it's not a ton of traffic. a lot of your clients are still connecting to APs with single user. So it's getting more prevalent, but it's still a long way to go, in my opinion.
Very good. All right, we've got another one in the panel here from Julio. What would be the recommended number of SSIDs per radio?
That's a difficult question to answer. I typically will say 3 to 5 max. Um, there's a very good website. Um, what is it called? revolutionwifi.net maybe. I don't remember who does it, but they have a very nice SSID overhead calculator you can use to kind of quickly and see what adding a new SSID will cause your environment to kind of see in terms of overhead. I
All
can find
right.
that, Heather, and you can include that in
Yeah,
the slide deck.
that would be perfect. We got another one. Oh, it's escaping me now. Bangani. On public Wi-Fi hotspots, what are the best APs to use?
I don't really know, to be honest with you. It all depends on the environment. Um, I know a lot of the wireless ISPs that I have dealt with in the past use MikroTik or Microtech APs. That's what a lot of the kind of Wi-Fi ISP solutions that I've dealt with in the past have used in terms of a vendor, but like specific AP models, I don't know, to be honest with you. It's more just looking through data sheets and finding an AP that has the features and the requirements of what you're looking for specifically.
All right, got another one from Bree. You mentioned limiting SSIDs per AP. Does that mean you might need more APs to support the coverage area?
No, not really. So the per SSIDs um is strictly just an overhead for the specific channel. So covering the serve or covering a specific coverage area, that's more just with the specific radios. So that's more power, what power levels you're utilizing, and the kind of the antenna array of a given AP. Hopefully that answers that question.
Oh, got follow-up. In terms of 2.4 gigahertz, isn't this band great for distance and better penetration?
Yes, yeah, it significantly goes further and penetrates more than 5 gigahertz and even 6 gigahertz. So typically, if you're trying to overlap a 5 gigahertz uh, coverage cell to where it mimics a 2.4 cell, you're gonna have to up the power of the 5 gigahertz by like I don't know, 3 dB at least over your 2.4. So typically APs will have the 5 gigahertz radio powered higher than the 2.4 to kind of force it to go as far as the 2.4. That's kind of how we get around it.
Um, got another one, maybe the last one here from Jerry Jones. It's a little difficult to read. What is the rule of thumb supporting PoE plus or PoE plus plus? Is the application of AP or new AX throughput and management? Does that make sense to you?
Uh, yeah, the rule of thumb is really just look at the features that would be enabled if you use PoE plus plus versus PoE plus. Um, Again, that's all specified in an AP data sheet. So if you're looking at the AP, um, if you're looking at the AP from like the manufacturer, that kind of thing, uh, it 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 will specify if there is a feature that will be disabled using PoE plus versus PoE plus plus, that kind of thing. So you just need to figure out what's required in your environment, and if you're not utilizing the features of that require PoE++, you don't need to have that level of power for your APs.
Gotcha. All right. And Jerry Mayfield asks, in a controller-based environment utilizing jumbo frames, does the AP automatically support those frames, or does it need to be pushed from the controller?
I don't know if I would say it automatically supports those. You'll need to configure jumbo frames kind of throughout the network as well. So yeah, it's a little trickier than just enabling it on your AP, where if the backhaul from the AP to the controller does not support jumbo frames, you may have some issues there.
Okie doke. Abraham asks, would you recommend to use mechanisms like band steering with Meraki or band select with Cisco?
Yeah, I would definitely recommend it. It doesn't always work, to be honest with you, because the client at the end of the day is the one that's making the decision uh, on what radio they're connecting to. You can kind of say and suggest to the client, hey, you may prefer to be connected to my 5 gig radio instead, but it doesn't always work. So it's nice to at least have the option for it.
Okay, and then last one. This is also from Bree. It's kind of a follow-up to the previous questions asked. And it's asking about 5 gigahertz. I'm experiencing that more APs need to be deployed for 5 gigahertz due to the coverage area being more concentrated, but smaller in terms of coverage. Are you seeing similar?
I think I think a lot of it is not so much coverage area. It's changing design philosophy, in my opinion. So, kind of the early days of Wi-Fi, it was coverage area is king. We want to make sure that no matter where you go, you have coverage area. That doesn't really work these days because Wi-Fi is more of a mission critical service. So you also need to deploy for capacity. So you're designing more for capacity these days than you are coverage. So in order to accommodate more clients, you're going to need more APs to accommodate those clients. But specifically, if it's only coverage area, and if you're comparing a 5 gigahertz coverage versus a 2.4, then yes, you will need more 5 gig APs than you would only 2.4. Yeah.